Okay. Well, hello, I'm Shawn Dolan, and I'm here to tell you guys about the latest developments in visible mission management and the ability now exists to be able to speciate the sizes and the concentrations of the PM that's in that opacity. Now have the ability to be able to tell you the presence of volatiles also in that one. And so things are moving along, things are moving along. And all of the science is progressing faster and faster and faster every time. That's one of my favorite shots. We do a contract for the national parks and managing the visibility. And good news about visibility is it's the exact opposite of opacity. So it's easy for us to do both. Just turn the equation upside down in the software, and all of a sudden we're reading just how far can you see before it reaches 100% opacity versus how much opacity is in that particular stack, and how much is it impairing my ability. And what you see here, I always use this as my example for anybody who's ever been to smoke school. You all have dealt with the white smoke and black smoke plume, right? So this is looking all the way across the Grand Canyon from the south rim to the north rim. And the white smoke that you see there is a controlled burn that they're burning off fuel and trying to keep the place from going into a massive forest fire. And then the black smoke is an RV on fire in the north parking lot. And that's the result, i.e. the catalyst, if you will, to the forest fire that they're trying to prevent. So at any rate, this is, we're going to talk all about a product that's called the Digital Opacity Compliance System, which is a product that follows a series of standards and a series of regulations that have been promulgated over the last decade. To kind of quickly give you a quick history of the company and the product line. We started this back in 2004. And the idea back then was we were invading these countries and we had to figure out how that was going to impact the troop stream. So the real issue was, you got people marching behind these columns of Sherman tanks, you got all this dust, you got all these issues, bombs, everything going on. So what you want to know is, when my people get into the battlefield, are they going to have to deal with fight? Or their lungs going to be so hurt and they're going to be so down. So they call that troop training. And so we were involved in a classified contract back in 2004, 2006 that allowed us to be able to develop technologies that would allow us then to be commercialized for other purposes, if you will, beyond just measuring the air and what that contamination, if you will, had to do with the impact on troop stream. So we started off with this product. We call it the Digital Opacity Compliance System. The little box you see there. It ran on a laptop, had a camera, and you put 3.5-inch floppy disk into the side of them, took pictures, and then you moved them over. And that laptop was more like a Sun workstation. So it really wasn't a very portable system, but it was the first generation, and it was something that we had very good control over the user base. So as a result, we didn't have a whole lot of errors, we didn't have a whole lot of issues associated with operator error. And because we had a very captive audience, if you will, there was multiple analysts on that team, and all of us, we're doing building software, so we had expert users all the way around. Then we moved into Docs 2, and we commercialized the first piece of that Black project, and that was the ability to determine opacity values. And so that became a commercialized product in 2006, and was the genesis of a company called Virtual Technologies. My company that we transferred that technology out. There's 3 other technologies involved, 2 of which now have also been commercialized out in my company. And the 3rd one is still pending release, but and we'll talk about those as we go through this life cycle. But essentially, we figured out how to do this troop trick thing way back when, and now we're trying to move that product line into the commercial environment so that we can reuse that technology to make everybody's life a little bit easier. Docs 2 was was the 2nd generation, where we basically split apart the particular parts of it and focused it only on opacity, and then we moved it into a laptop instead of a Sun workstation, and we made it more portable and more reusable. Problem was that we went into the field, and this is the same problem that I can see with the optical gas energy regulations that are happening, is that the operations of anybody's software are just enough different to where if you don't have a specific training course for that guy's gun and that guy's camera, then you're probably going to misuse it and you're going to get bad information. So the real key to all of these types of technologies, whether it's mine or clear camera or whatever, any kind of optical gas imaging system, is really have a good training in how you're managing that data and how are you consistently capturing that data. That's really the most important part. So most of my customers now have gone away from these ideas of handheld cameras and they've gone to fixed mounted cameras. So the cameras are more steady, the cameras are more consistent. It gives us a much, much better read, if you will, on opacity as well as the ability to speciate. You cannot speciate from handheld cameras. Now that fixed mounted camera, we got to be dead still. In order to do the speciation, because we're using light diffraction to be able to do that. Hear more about that as I move through this presentation. So we went to Docs 2 on the laptop, and the big problem that we ran into there was that people were really focused on the software and trying to make the software work, but they lost focus on the most important part, which is capturing the picture. At the end of the day, boom, in that picture is the little bitty thing. You can't see it really well in the picture if you're not going to be able to tell it fast. So anybody that comes to my certification course tomorrow will learn all about how to frame a picture, how to get a third of the picture and be fluent and so forth. And we'll be running the actual software and the certification course here tomorrow. If you don't have time tomorrow, then you just call me up and tell me that you were in this course and do the certification over the web as well. But anyway, Docs 2 became the first, the yellow box there really wasn't as usable in the field as we wanted it to be because we didn't have good oversight. That was really the problem. So every time I had a customer and they said, well, the thing's telling me that it's 30% opacity, but I think it's more like 50, and I've been going to smoke school for 20 years and blah, 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 blah. And so, but I can't see the picture. So I said, all right, enough of this. So we went to a web-based system, Docs 2, the green box. And which now allowed us to be able to see everything that people were doing. Now we had insight and oversight, and we were able to now get rid of all of the doubt with respect to whether or not this system actually worked, which was the beauty of it. About that time was coming of age of what they call software as a service. And Docs 2 was released as a software as a service product so that we could get through all the security hoops and so forth that we have to get through to be able to do business with the federal government. This software is used for enforcement throughout the United States and various enforcement agencies all over the place. The names go on and on. I won't do too much of that. But now we're doing the purple boxes down there at the bottom, the Docs 3 SAS, which will be released probably in the summer. We just finished a big study. I was working the spreadsheet for earlier, but to essentially, this is looking at copy registry of all things. But constantly a comparison between human method 9 cameras and Docs, and what we find out is that Docs is a little bit more. We won't say accurate because method 9 is still my reference standard, so I can't be more accurate than my reference standard. But what I can be is more reproducible, more repeatable, and that's where we're at. So we still have the same tolerance levels, plus or minus 15% on any one read, 7.5 over the set. But we also are very, very consistent in our things. The other thing that we've done is put in this next generation is this Docs 3 is that we're speciating out the criteria pollutants in that room, and we're able to tell you by concentration. I can't give you parts per million because I don't have volume. But for instance, if my customers will give me the air volume going through that particular stack at the time that we took the picture, then we can get the part. Because I only have a picture without how much air is actually there, all I can give you is what the percentage is. So there's 20% being 2.5 is smaller, 20% between 2.5 and 10, and the rest of the 10. You'll notice about what everybody's hearing about this environmental justice stuff, so I put this last line on the slide. But the real difference between point samplers that are going up all over the place in neighborhoods, especially in California where we're doing a lot of these wide areas, the downside to point samplers is that they only sample right there where they're set. And so they get the visas drops and flare drops and get everything on the road. So it's hard to really say that this particular problem is coming from that facility, things of that nature. So now we've gone to these wide area sweeping monitors, which is essentially a stick that looks not unlike this, and it's got camera on the top of it, and it just sweeps around the circle. And it's just constantly sweeping and sweeping and sweeping and sweeping and measuring everything that it can see. It's good for about a quarter of a mile in each direction. And so they're really wide area monitors looking for opacity sources and looking for big pockets of particulate. And then the other downside to the point samplers is that they put up one of those air benches in downtown Chicago and park, and it's gone the next morning. So they finished it at 5 in the afternoon. Everybody had their celebration. And they, oh yeah, we got a big park bench, and it's an air monitor and an air station. The next morning, when they went back to go do another photo op, the whole thing was gone. And that's a serious problem. I had no idea what the problem that was. A friend of mine, Nick, was working with me up here at the Starbucks coffee roasting facility, and we were talking about community monitors in his neighborhood, and he lives kind of like Compton in LA. And he was like, Shawn, we can't even keep catalytic converters in our car. People are probably going to need their saw on the mountain, so the monitor on the street corner. That's just crazy. So the good news is that I put up that last one, these are up in the air and out of pistol range. You can get them up 60 feet in the air, and it's pretty hard to hit them with pistol. A lot of them are not. Evolution of docs, and I won't go through all of this in detail because it takes too long and it's too boring and nobody really wants to know. So the highlighted on the bottom of it is really the bullet message, but we started back in 2000. I talked about, we went through the technology transfer network. We created a standard called ASTM G7520-09 back then, was when it was originally published. The 09 version had a 7-foot stack limit in it because the EPRI folks didn't want me to get this standard, so the horse trade was exempt 7 feet stacks and like that. So I did that, and then we did some more studies, and the 16 version of that standard eliminated that exemption. So now it's good for all opacity sources, whether they're mobile, stationary, computer, or area. So we're monitoring forest fire. We're monitoring dust storms in Arizona. We're monitoring dust across the freeway in Arizona. There's a place out in Arizona called San Simon where we've lost usually about 10 people a year to dust storms. And for the last 2 years that we've had dock system monitoring, shutting down that freeway when the opacity is greater than 60%. We have not had a fatality on that stretch of road. So it's a real big success story. So we are one of the few broadly applicable standards. US EPA alternative method 082 can be used in lieu of method 9 for all orders, CFR 60, 61, and 63. So unlike most alternative standards where they are locked into a specific type of industry or a specific type of process, that this standard can be used in lieu of 301 for this or for that. And so we're broadly applicable to use across the board. Very, very hard to get that, and it has to be tested on all the different platforms and so forth. But broadly applicable is really an operative word in this particular area, and then due to our track record in the courts, we're known as the most credible evidence. And we've never had anybody truly go against us in terms of wanting to fight it out all the way through a jury verdict. So we've never, if you will, you're a lawyer, you would say, have you survived a jury verdict? And the answer is no, we haven't had a jury verdict. And the reason is, because every time we've been in 20 some odd of them, but every time the judge says that he's going to allow the pictures to be entered as evidence, the case gets settled within an hour. Nobody wants those pictures. Put them in 30 days. Better off to just sell it. So that's kind of the way it is. Then we went and did a big fugitive dust study so that we could do dust. That was what led to the thing on Interstate 10. Federal Valley NESHAP was published back in 17, denoting us as best available control for process fugitive emission. We came up with a product called Flare Watch that we built in 2018, and another one for doing heavy duty diesels. It's essentially the same thing in 2019. Unfortunately, I had some developers that got COVID and didn't make it, and so that kind of slowed that one out as far as the release. We didn't make a 2020 release, so we got them in 2021. By the time that was a deal. I had to kind of rebuild my technology, my bit twizzlers, as they call them. Yeah, they had to get regrouped. But we are the only ASTM 7520-16 certified software product on the market that I'm aware of. And being as I'm the chair of the committee that manages that standard, I would assume no out there. I keep encouraging more because I would really, truly like to see some competition. I think it would add credibility to the product. But why are we here? Well, we're here because people complain about what they see and what they smell. At the end of the day, that's what they complain about. So we're monitoring fence lines for contaminants that you can't see, which is a great thing to do. But if you look at complaints and what's driving the problems at the regulatory agency, it's the guy on the phone saying, I'm seeing this nasty fluid coming out of this thing, it's going right in my bedroom window, and I just can't stand it. So it's what people see and what they smell, what they complain about. And that's really where Doc shines, is that we are the people that define what exactly can you see. And who agreed with us on that? Well, we were really lucky early on. We got a contract with General Electric. And General Electric, we manufacture a coal-fired power plant all over the world. Most of those coal-fired power plants being, being funded by the World Bank. And the World Bank promulgated some regulations at the behest of GE that the World Bank put out a thing, and they said if the project will generate more than 20% opacity, we will not fund it. And that was something that GE took to heart. So we got Doc Stanford, who went all over the various different facilities, construction projects all over the world. It was quite a fun trip, and we documented that even at full burn, they were not burning more than 20%. By doing that, they were able to get their money, and the World Bank adopted DOCS 2 as being the means by which, if we want to prove this, is the preferred means to do it. So visible emissions driving worldwide environmental awareness was really, it was surprising to me that the World Bank would put that kind of a restriction on their money. So that was, we heard it in the plenary session this morning about environmental justice and socially being good and all that. But this was really actually putting it to the test, and that was back in 2015. These are some of the customers that have been around for a long time. I just added that Coke logo on there for you guys. Took away Golden Specialty, although I really like Georgie Golden Specialty. He's not as big as Coke. But at any rate, all of these customers have been around since we started. Probably the real one on the top up there, Carbon County, is the smallest of all of my customers, but they were the first. And what they bought DOCS for was they were in the middle of a litigation. The Sierra Club on one side with Method 9 readers saying that these trucks that were driving up 7 Mile Canyon were doing 60 and 80% opacity and ruining petroglyphs, ruining the road and killing the tree squirrels and everything else, and they need to shut down all that stuff. And then on the other side, they have everybody called and was trying to mine the shale down the bottom of it, driving these trucks back and forth, and they're saying, no, we've got 10% opacity, we're doing everything we can. Not a problem, and blah, blah, blah. So they're in the middle, and they're going, we got it. So what they found out, we were at Hill Air Force Base on an open day, and guys from Carbon County showed up at the behest of Utah Department of Environmental Quality, and they took us out there and they said, why don't we just use this product to decide who's right and who's wrong? And so we did that. But nobody wanted to discuss who was right and who was wrong, but what that did was it got everybody to the table and they came to a resolution. They've been fighting that for over 5 years. So I give you that idea. What they ended up doing was paying the road, which was a great idea. And so Peabody Coal put up the fight to pay the road. They got their money back through reduced tax on the natural resources they were trucking out of there. So they got the money paid back to them, and the maintenance on the trucks went much lighter. The Sierra Club got the tail on it, so all the petroglyphs got the word, and everybody was happy. So a real big success story. So even though Carbon County only has 2 people in it that know anything about DOCS 2, that's one of my biggest success stories. Is we saved 7 Mile Canyon, if you will, 9 Mile Canyon. I'm sorry. This is basically how the system works. So you're out in the field, you capture the picture. You can do that on a handheld, if you will, if you want to mark where am I standing, where's the sun relative to all that. So those handheld mobile devices, and it runs on Apple or anything, Android. So that'll tell you all of the information that you need for a Method 9 report, captures it right there on your hand. So it knows where you're standing, you're getting the weather from the closest NOAA weather station. on and on and on and on. So none of this guessing and trying to figure out where my relative is and all that kind of stuff. So all that information goes in, you take the pictures, you can either transfer the pictures from the camera to the left or to the handheld and then up to the web, or you can take them through the SD card, down to a laptop and then up to the web. Either way, they end up in the web, and then the capture web is going to get analyzed. The beauty of this is that you got a third-party analyst, so the person who's doing the analysis doesn't necessarily know what the permit limits are. That's what makes it a beautiful code. Because what ruins method 9 is not that method 9 is a bad method. It's not been certified for over 30 years, so I believe in that. But what I don't believe in is that there's not bias in the method from the guy who's working at the plate, because he knows the limit's 20, so he can't see 25. He can only see 20. He knows it's 20. And or she, it's not gender specific. Can go either way. But as a result, we kind of feel like, by moving this into a third-party environment where they don't know what the limits are, they're just strictly looking at them, being able to use software to gauge at them, that it makes it a little bit less biased. Plus, it's a nice pretty report with the thumbnails and pictures. And the operative piece of this is that the part that you see that's kind of an eye chart on the far side next to the thumbnail, that is where the opacity was measured to the pixel. So we're X and Y and Z in terms of where did we mark the plume and where did we mark the background, how did we, i.e. how did the software come up with that number? And so it's very repeatable. So in the event that people say, well, I don't believe that, I can take a picture, move it back up, and put the cursor on the same 2 spots in accordance with those coordinates and go on the same time. There is also a self-test requirement as part of the standard, so every time this thing boots up, it has to run through 300 photographs and come up with the same answer that it did when it got certified. So that's another thing that keeps it going. So the bottom tag on this one, right? So back in the days of Ringelmann, anybody who's been 99 trained knows that we were using Ringelmann numbers back in the 1800s to determine how to get good efficiency in our pole burns. And so essentially we're doing the same thing here by looking at combustion and the opacity that is being generated by the combustion activity. How do we compare with method 9? Well, with method 9, anybody who's done method 9, essentially you go to smoke school every 6 months, recalibrate your eyes, and you're good to go to read smoke. The downside of method 9 is, again, it's not repeatable nor is it reproducible, but it is a very accurate method relative to the bias that is inherent to the fact that no real cross-check on it. Good news about us in EPA alternative method 82 is very much the same in terms of durations and so forth, but we have 2 levels of certification. So we have a certified person who takes pictures, we call them digital camera operator. Those are the people that capture the imagery, and those are the people that have gone through the certification course and understand how pictures need to be framed and so forth, so they can dial in camera and have a good picture. The next tier above that, if you will, is the analyst training. And so most of my customers don't have analysts on the site. A couple of them do because they generate enough volume to where it allows to be able to do that. But the vast majority of them just outsource that process to us as virtual technology. So we have a facility in Sri Lanka that is kind of right in the middle of a war at this particular moment, but they're still doing analysis work. So we do operate 24 hours a day, 7 days a week. And so when we're not doing it here in the U.S., it's just the phones over and they all go to Sri Lanka with exactly 8 hours from Arizona, or 12 hours, from Arizona, so it makes it an easy switch. But what we have to do is we have to certify our software. Got to go through 6 smoke schools in a row. Can't fail any. Fail and do another 6. So 300 images can't miss by anything like a human can, right? So we're held to the same standard. We can't miss any one by more than 15, and we can't have a deviation greater than 32 or 7.5% over 87.25. So just like a smoke school, only the difference is, and in fact, we actually do this through Technical Associates, my business partner. But the difference here is that we do 6 of them in a row, and once we do 6 of them in a row with 300 images, and we pass that, now we're certified. I'm certified for 3.5 years. Every 3.5 years, we redo that certification. over and over and over again. And I told you earlier about the self-test that happens. Then when we train field users don't really ever have to go back to smoke school. Why? Because we're looking at the pictures. So we know whether they remember what we told them in class or not, because we're looking at the pictures. The pictures come to us and they're just this little bitty plume, and we pick up the phone and call them back and we say, hey, remember that slide 32 at 9 o'clock? Why don't you drag that back up, get a look at it, go retake the picture. So through that oversight and that insight, we're able to keep the quality very, very high on all of the things that we're doing. We operate unlimited backgrounds, unlimited weather conditions. I passed a white smoke school run in Salt Lake City, white snowstorm. Not a single person, human, 120 people in that parking lot, the only person that passed was me and him. It was a tough school. tough school. But we also do it at night. We've been certified by CARB to run night schools, and also certified up in Alaska. And I'm trying to remember that smoke school operator up there, EM or something like that. But so anyway, we're essentially held to the same standards every time, and we got to do 6 times. And so I can't say that I have a harder criteria. I just have more. But that makes sense because computers are repeating. So if I can do it once on a computer, I should be able to do it 8 times. That's the idea behind it. So this is back to my old business partner, Tom Rose. The guy who did it at the time. Was one of my development partners on this product way back when. So at A-Rod, I asked him, he was one of the most noted expert witnesses for visible emissions, been in court 78 times for both sides, won every single one, always on the winning side. And so I asked him, I said, what are the 3 main things that get at the 9 to court? That's what he gave me. So when we built docks, we made sure to solve all 3 of those 3 big nuts. And the record not being technically correct, and the software is really good for that. Right? So there's not a background value. I'm going to give you an error. Say, hey, you got to put in a background value, right? Versus a hand-filled sheet. And this is the background value you never know until the inspector pulls it out of the fact sheet. Says, how come it doesn't say background value? So for that reason, we're able to solve number 1 because we've got all of the internal references of any kind of a good software system to be able to do that. The V not being performed by a certified observer. Now here we have another issue where, what Tom was always telling me, and I've experienced it myself, where I just couldn't get to a smoke school to perpetuate my certification in a time period that, because they were in some kind of place, or somebody got sick, or whatever happened, and I wasn't able to go to it. So as a result, I'm not certified, but I still got a monthly reading requirement at my facility, so I'm going to go ahead and do it. Because I know I want to do that, but I'm not certified until next week. So what happens is there's some type of an issue, and then they go back through and they audit that with the smoke school records, and they find out, well, you weren't certified when you did this, so how it goes. So that was the other one. So because we're a 2-tiered thing, that's why we never expire our certifications in the field. So once you're a digital camera operator, you're always a digital camera operator, as long as you send me good pictures. So it just keeps perpetuating. So you don't expire if you go like you do. Now my analysts they got to stay in smoke school, and they got to keep their certification. And but those are the guys that are doing analysis, not the people that are capturing pictures. So the field does picture capture, also everybody who's doing analysis work is not that they really need to be, because the software does most of the work, but it keeps us on, so to speak. And this is the question that everybody always asks me. And they say, well, how does this compare to you? So I always say, if you can find me a Method 9 reader who has passed smoke school for over a decade, any mistake, 6 months, with a deviation less than 15, I'll buy a case of beer. Nobody I am bought anybody a case of beer. Docs has done it and continues to do that. Our deviations, if we're on a good high contrast day, our deviation percentages are less than 15. Most people, humans, who go to that same school, and this was done, we did an audit of all of the carb smoke schools, 2011 to 2015, and you'd be surprised how many people got certified, shouldn't have been, and how many people failed, that shouldn't have failed, as a result of mechanical issues associated with depends on a transmissometer dropping and hand transcribing that value. And, those errors, transcription errors, regular, data entry kind of stuff. When we had 3 of them, where we noticed, looking at the camera and read back the answers, and I'm going, 35? No way. So I walked over and showed them the picture, it was clearly a 65 or 70. And I'm going, I can't be, so they go in there and they recount. And they read it and they find out, oh, wow, we had a double pin drop here, so we're off that answer. So we'll redo all the answers. Get out that mistake, 70 people who would have failed passed, and the 30 people that passed, thought they passed all day because of the switch. And that's happened more than once at every smoke school that we've ever audited. So it is really something that happens all the time. But anyhow, our deviations are always going to be less than 5% if we've got good high contrast, blue sky, light, blue sky, black. We're always going to be within 5% of any transmissometer that's out there. Transmissometers float 3%, we're rounding to 5, so it's hard to say which one's really more accurate. I've always contended that DOCS is probably more accurate for the opacity than any common insect. And we've had a series of tests that talk to that are up on my website. We can be used in rain, snow, trees. But what I will teach everybody in course, if anybody goes to the certification course, is try to stay away from stuff that moves in the background. Anything moving in the background is not good for us. It's great for humans. So human always wants to line up to a tree. Because if you can see the leaves moving on the tree, it's less than 30%. If you can't see the leaves moving, then it's above 30%. Most of these smoke schools nowadays only go from 0 to 60. I almost guarantee it fast. So happy to look at the tree, I can't see it, and I guess 45. When I look at the tree and I can see it, I guess. Oh, be pretty close. So if you just know those kind of secrets, you can get through the smoke school pretty easy. But anyway, now as the we start getting white smoke against heavy overcast white clouds, and that's where we're going to start deviating more than 10%. And we're getting up to the 10% deviation, where you put black smoke against a dark green tree that moves, and that's where you're going to see up to 10% deviation. That's when the humans all start feeling smoke. So you get a white smoke against no gas data, you're white, most of the humans don't. Black smoke against hard trees, dark green trees, most of the humans don't make it to smoke school. DOCS, like I said, we haven't failed smoke school for as long as I can remember, and I started keeping track back in 2011. DOCS every 6 months. How long it's been, but it's been a while. The other thing that people ask me is, well, how do you know there's not water? Water is always everybody's out, and rightly so. But a lot of stacks, they'll saturate with water just to kind of cover the opacity, so to speak, but and or to wash out the pollutants. So what you see on the top right-hand side up there is the original picture. When you start dropping down, those are the filters that are dropping on. The top one is a water filter. So what shows up in the water filter is where is the moisture in the plume, and it shows up as dark black. So I know not to put my reed boxes in the black. So I stay away from the black. The next one down is show me where there's a lot of particulate. 2, 7, 10. Oh, the other way around. Sorry. Starts 10, 7, 2 is the way around. So those are the filtration systems that we're using from the image to be able to find, if you will, the species. That's how we do it. We now have another one that does VOCs, but I haven't quite got there yet. So essentially what happens is people sit in those pictures like you see at the top up there, and then we drop 2 boxes on those pictures, which should show up on. You see the yellow box in the plume and the red box on the other side. The yellow box goes in the plume, which is where am I going to read? The orange box goes outside the plume. What am I using my back with? So part of our training course is to make certain that when you take that picture, that you have something in the background that represents what's directly behind the photo. That's essentially what we're trying to do. Now we do another, what we call and this is how speciation works actually, where we do a fixed mount camera and we do a single picture with a zero emission in it. And then from then on out, we use that picture as the background, we overlay that ASCII picture, if you will, put a single box on the picture. As long as the two pictures resolution is the same, i.e. why the camera can't move, okay? Then what we're doing is we're saying, well, we know what zero is from the zero image, and now we know what this other one is if we calculated that on. So instead of picking two spots on one picture, we pick one spot on two pictures. That's much more accurate, one spot on two pictures, but you have to have a picture of your source without emissions on that. Most people that are using the software are either looking at dust or they're looking at stuff that's intermittent. So it's hard to really get a good zero image where they're going to be standing. Or it's a continuous source that never really shuts off, so it can't really get that picture either. But my customers that use that feature are people that are in like the grain loading business, where they have auto emission issues and, capacity over 10% blows up. So in that case, we use that, we do opacity down to the percentage level, 1, 2, 4, that are around 5. And when it gets to 5, we slow down the belts. When it gets to 7, we shut them off, so that they don't have class safety issue associated with it. So docs can do it at that level, but again, it's very specific to that particular operation. And those cameras can't move at all. So this is kind of our regular compliance area. We different products that we do. They all work within the software as a service cloud, if you will, the center part. And then as you come out and towards me, this is a set of the one on the top is kind of the standard kit and regulator in Arizona, Wisconsin, Michigan, Minnesota, New York, California. Bob is going to be carrying around out in the field, and Oklahoma. So it's a handheld video camera. Video. I always say video. I get that out of it. It's K2 or else I would the rejuvenation video camera. But high definition recorder. And so that high definition recorder right there, you just set it up, push the button, you let it run for 6-7 minutes, and then you upload the MP4 file. When you do that, the software will cut that piece into one image every 15 seconds, load it up with your observation. The stationary cameras that you see there in the bottom corner, those are what we're using on the overheads that are watching for trucks and the overheads that are looking at flares. Those are stationary mounted and they're all weather cameras. So they're in a vestibule so that they don't fog. They got heaters inside them, keeps them from fogging out on cold weather and so forth. We got those cameras on a company called Maynard Steel up in Milwaukee. And last winter, I'm trying to remember what was unbelievable. I couldn't believe it. The guy called me up and he said, well, 35 below zero and the wind blowing 45 miles an hour. Do you think the cameras will work? I said, I'll log in, try it. Sure enough, they worked just fine, but all you could see was white snow everywhere. It was interesting. Quite a good thing. So at any rate, on these watch systems, the way they work is you have a mounted camera. That camera is basically mounted and it's constantly streaming to a localized file server. I don't like what you guys are doing. And then you just upload from that file server to the web. And so you're not really taking those video files, all of it, to the web. You're only the step that you want to actually do that's the job. And then on the other side that you see over there, those are all of our community components. And that one that you see in the far upper right-hand corner is one of those towers. I was telling you about like those that go in people's backyards that complain. In the state of Arizona, if you complain, you get one of those in your backyard for a month, point it up wherever you're complaining at. And but your obligation as a citizen to complain is to power. Because they got plugs in them instead of solar panels. This one that's a picture of one with the solar on it. Those are used at the mining operations in Arizona. All of the big pit mines doing dust monitoring, and so they don't have power for the solar. This is a little bit more exploded view of the flare system, and at the time we got here. So the flare system again is, same idea. We're just watching a specific point. We have a fixed background. So when that background changes greater than 20%, then we start recording. So this is using a technology called HP65, which has been developed in the CCTV cameras for over 30 years. But it's essentially a technology that says what has changed, what has changed, what has changed. So you take a baseline image, then you're taking 30 frames per second. But the only thing that you're transmitting are the changes. You don't transmit the entire file, you only transmit one change. Show up. So that gives us the ability to move big files, if you will, video files, MP4s across the network without having 700 megs that we got to go through. This is a fugitive emission, again, one of those backyard systems, and also a complaint management system that we do. This is for doing multi-part surveys. So another feature that this has is if you have more than 10 or 12 emission sources in your facility and you want to just kind of walk through and watch, and you have in your permit that you're able to do that, they call that instantaneous opacity watches in Arizona. But so if I'm a sand and gravel operator, I don't have to do a method 9 on everything, but I do once every morning, every afternoon, I have to do a walk through my place and verify that I didn't see any visible emissions that are greater than what my permit value is. And if I did, then I have to do that. So this was built for our customers in Arizona who deal with that, and I found out that that particular law seems to be going all over the place. This talks about our heavy-duty I&M vehicle. So here, what we're doing is we've got the cameras up in the overhead. The trucks drive through, and when they drive through, we're sensing the air that's going on using video, and we're looking for heavy diesel particulate. If we see it, and we grab the plate. That plate goes to the whoever the local enforcement agency is, and they pull it over and do a full-on inspection on the vehicle. This is a complaint management system that we developed for the Positions for Clean Air, I believe it was, and Positions for Clean Air in Utah. And then the Families for Clean Air really were the people that ran with it, and that was a Bay Area organization out of Marin County on the far side of the bay. And they were having a bunch of issues with localized polluting sources. So we did this. This is an interesting story. We did this and we gave it out to the community schools. So we went to 6th grade kids and we were not teaching them about air pollution. We made these cool colored books and had all this neat stuff, and we're showing these kids this. It was amazing how much those kids knew about the neighborhood and where all the thing was. Right? But all of the emission sources, all the fugitive emissions, kids knew exactly where it was. You give them a map and they go right there, right there, right there, right there. The downside is about a third of them turn out to be crack houses. And so that kind of took the cake off a lot of life, because last time they gave it to some kid, didn't kill it. So that kind of slowed everything down, and so we got out of. We're still doing the education, but we're not encouraging kids to go out and find that stuff. Yeah, using the sweepers. It's too dangerous, and the last time we would stand to be doing that. But these are what those air monitors look like. This is a full trailer version of it. That's solar powered. Tow it around, park it, and up on the top up there, you got cameras as well as a weather station and a transmitter. So that all runs over cellular, and you're feeding real time at all times. And then this little one here is not as portable, obviously, as a trailer based one. But again, just used in like backyard. So and these are all pictures that have come in through that Spot the Smoke program over time. And this is the next generation of the stuff. This is when we started doing the speciation out on my ranch in Arizona. And this laser, this green laser here, is what we're using as our backscatter technology to be able to verify and validate that our opacity cameras are coming up with the right densities and the right concentrations of that dust in the various different sizes. So with that, we've made it to the end of the presentation.